A rocket stove is an efficient cooking stove using small-diameter wood fuel which is burned in a simple high-temperature combustion chamber containing a vertical chimney and a secondary air supply, which ensures almost complete combustion prior to the flames reaching the cooking surface. The principles were described by Dr. Larry Winiarski from Aprovecho in 1982, and stoves based on this design won Ashden Awards in both 2005 and 2006. Interest in rocket stoves has led to the development of rocket mass heaters and other innovations. Design: a rocket stove achieves efficient combustion of the fuel at a high temperature by ensuring a good air draft into the fire, controlled use of fuel, complete combustion of volatiles, and efficient use of the resultant heat. It has been used for cooking purposes in many energy-poor locales as well as for space and water heating. A rocket stove's main components are fuel magazine, into which the unburned fuel is placed and from which it feeds into the combustion chamber, at the end of the fuel magazine, where the fuel burns, chimney, a vertical chimney above the combustion chamber to provide the updraft needed to maintain combustion, heat exchanger, to transfer the heat to where it is needed. The fuel magazine can be horizontal, with additional fuel added manually, or vertical, with fuel automatically fed. As the fuel burns in the combustion chamber, convection draws new air into the combustion chamber from below, ensuring that any smoke from smoldering wood near the fire is also drawn into the fire and up the chimney. The chimney can be insulated to increase the temperature and improve combustion. According to studies, this can increase efficiency by up to 2%. In a rocket mass heater, the heat is passed to a heat exchanger to ensure the efficient use of the generated heat. For cooking purposes, the design keeps the cooking vessel in contact with the fire over the largest possible surface area. A pot skirt can be used to create a narrow channel that forces hot air and gas to flow along the bottom and sides of the cooking vessel. Optional baffles guide hot air and flame up the sides of the pot. For space heating purposes, the heat is transferred to a heat store which can, in some cases, be part of the structure of the house itself. The exhaust gases then pass out of the building via the chimney. The design of the rocket stove allows it to operate on about half as much fuel as a traditional open fire, and it can use smaller diameter wood. If the stove is insulated and raised from the floor, the danger of children burning themselves is reduced. Some more recently designed rocket stoves are self-feeding, using gravity to add fuel to the fire as required. Recent adaptations: there have been a number of new cook stove designs based on the original rocket stove. Many are being developed with alternative fuel options, such as solar-powered cook stoves. Designing stoves that generate electricity is another emerging trend. For example, the BioLite stoves use a thermoelectric generator to generate electricity suitable for powering USB devices. History: a precursor to the rocket stove was the Argand lamp, which was patented in 1780. This was a major development of the traditional oil lamp, which introduced a glass chimney above the flame to increase airflow. As well as being used for lighting, this design was also used for cooking and heating water due to its affording much the strongest heat without smoke. Dr. Larry Winiarski, technical director of Aprovecho, began developing the rocket stove in 1980 based on a Vita stove, designed by Sam Baldwin, and rediscovered the principles of the systems developed by the Romans in hypercaust heating and cooking systems. TWP and Ardeza were winners at the Ashden Awards for Sustainable Energy in 2005 in the Health and Welfare category for their work in Honduras with the Justa stove, based on principles of the rocket stove. Aprovecho were winners of the Special Africa Award at the Ashden Awards in 2006 for their work with rocket stoves for institutional cooking in Lesotho, Malawi, Uganda, Mozambique, Tanzania and Zambia. Uses: cooking. The rocket stove was originally developed for cooking, where a relatively small amount of continuous heat is applied to the bottom and sides of a cooking pot. Stoves can be constructed from brick, recycled steel cans, or steel sheet metal, or can be purchased. Although rocket stoves are found more commonly in third-world countries where wood fuel sources are more scarce, they have seen in recent years increased use in developed countries, such as the United States. Some are small for portability, with insulation inside a double-walled design and a chamber for partial biomass gasification and additional mixing to increase heat production and to provide a cleaner, more complete burn. The advantage of rocket stoves is the very little fuel they need, such as wood and dry weeds, to be able to cook a whole meal with it, keeping the air cleaner with less hydrocarbons and carbon monoxide. Room heating. The rocket mass heater uses the rocket stove principle within a system designed to both heat air directly and also to transfer much of the heat from the flue gases into a thermal energy storage, often made of cob. Described in detail in 2006, these heaters are becoming popular with DIY builders, in natural buildings and within permaculture systems. Water heating. Rocket stoves can be used to heat water via a heat exchanger which transfers heat to a body of water in a nearby container. See also, airtight stove, beverage can stove, BioLite, chimney starter, Franklin stove, hobo stove, portable stove, rocket mass heater, fire pit, samovar, ECO zoom, Lucia stove, Kelly kettle. References. Further reading, Bilger, Burkhard. Hearth Surgery The Quest for a Stove That Can Save the World. The New Yorker, 21st and 28th December 2009. Pages 84-97. External links, Demonstration Rocket Stove for the Campus Center for Appropriate Technology at Humboldt State University, Step-by-Step Plans for Constructing Rocket Stoves, and Buying, Detailed Design Instructions from Aprovecho Research Center. Resources for wood-burning stoves from Aprovecho Research Center, Global Alliance for Clean Cook Stoves, 42. Agnes Klingshirn and Peter Scott. The FP Top 100 Global Thinkers. Foreign Policy. December 2010 A.